Okay, we are on page 189, and this is example 7. This is called a piecewise function, and it's kind of like a patchwork quilt where you've got pieces of one thing sewn to pieces of another thing, and you put all the pieces together and it makes a really nice quilt. Well, this will make a really nice graph when we put all these pieces together, but we have to figure out what the pieces are first. So stop the video and copy what I have here, and then when you're ready, start the video again. The example on page 189 says to evaluate the piecewise function when x is -2, -1, 1, 2, and 3. Okay, so they want us to evaluate the functions based on the value of x. So here's the piecewise function. Let me bring this whole thing down here. This is the function, f of x, and it has 3 pieces. When x is less than 1, we're going to use this piece. When x is, let me look at what I've done. -x, when x is greater than 1, we're going to use this piece. I didn't realize that was a -x, but it is. And when it is exactly 1, we're going to use this piece. So the piece of the function we use will depend on the value of x. So let's go in here and color code. That'll be a little bit easier. The first value of x is -2. So -2 is less than 1. This is going to be the yellow function. -1 is less than 1, so this is going to be the yellow function. 1 is exactly 1, so this will be the orange function. 2 is greater than 1, so this will be the blue function. And 3 is greater than 1, so this will be the blue function. So this explains how the pieces, I'll use 2 yellows, 1 orange, and 2 blue. All right, let's start with f of -2. That's a yellow one. And when x is less than 1, the output is simply x. Let me draw a line right here. This is not part of the function. That's telling you the condition. So if, let me do it this way. I don't want to confuse you. I know this is confusing. These drove me crazy in school. F of x is x if that x value is less than 1. So f of -2 will be -2. So let's put that in there. Then f of -1 will be -1. Okay, f of x equals 3 when x is exactly 1. So when x is 1, the output is 3. And that's this one. Okay, these are both the first condition. And then I have that third condition where f of x equals -x if the x value is greater than 1. So f of 2 will be -2, and f of 3 will be -3. And now we have the pieces of the function in the table. And we are supposed to graph this mess. Oh boy. Let me bring in some space for a graph. I'm going to try to just move those up there since we're finished with them. And here is a coordinate graph. Let's just draw one. We can do that because the numbers are pretty small. It doesn't have to be huge. So let me do that again, and I'll just put the graph right over here. So I want to stop. I just canceled my recording. Okay, let's graph the points. So we have -2, -2. That's right there. And I need to pay attention to what I'm doing here. Okay, and then we have -1, -1. That's right there. And then we have 1, 3. So over 1, up 3. And that is just a point by itself. That's not connected to anything. These 2 points that I drew first are connected because they're both yellow. Then over 2 and down 2. Over 3 and down 3. So these 2 points will be connected. Now, we need a starting point, and that's where we're going to go with the pieces of the function. So when x is less than 1, that means it cannot be 1. It has to be less than 1. So I'm going to put an open circle right here because it can't be 1. It has to be less than 1. And then I'm going to draw that function. It's going to go this way. This is the yellow function. So those yellow points we found, and that yellow piece is what makes that line. Now the orange one is just a point. It wasn't 2 points, it's just a point out there by itself. But then for the blue one, x has to be greater than 1. So I'm going to go ahead and draw an open circle there. Can't be 1, has to be greater than 1. And then let's make the function run this way. So this is the blue piece of the piecewise function. And this is the graph that we're using. You just have to graph all the pieces separately. Okay, let's do another one. This is also on page 89. This is Think About Math. And we have a piecewise function over here. Let me draw my little squiggly thing first and rotate it. I can't do that sideways. I can barely do it straight up. Alright, so here is that thing. So we have f of x, and it equals -2x. That's when x is less than 0. And 2x when x is greater than or equal to 0. So we only have 2 pieces in this function. The last one had 3. And if when x is less than 0, we're going to do this. When x is greater than or equal to 0, we're going to do this. So I'm going to build a table of values. Let me see. We have 1, 2, 3, 4, 5 points again. So let's make 6 rows, because we always need a header row to know what we're looking at. So here's this one. We've got our x's, and then we have f of x. So they want us to evaluate this function when x is -2, -1, 1, 2, and 3. So let's figure out which is which. I'm going to bring this right over here, a little closer. And remember, this has nothing to do with the formula. These are the conditions over on this part. You don't have to do anything with that other than figure out which piece goes where. So when x is less than 0, I'm going to use the blue function. This is less than 0, and this is less than 0. And then if x is greater or equal to 0, I will use the yellow function. So that will be all of these at the bottom. Okay, so let's evaluate. I'm going to use f of x is -2x for the blue pieces. So f of -2 is -2 times -2. So f would be, or f of -2 would be +4. -2, +4. And then that same function, f of x, is -2x when x is -1. So -2 times -1 is +2. So there are my 2 blue pieces. I did this one when it was -2, and then this one when it was -1. And now I switch to the yellow function. So I have f of x equals 2x for these yellow pieces. So f of 1 is 2 times 1, or +2. Then f of x equals 2x, and f is 2 this time. So 2 times 2 is 4. And then f of x is 2x when f is 3. So 2 times 3 is 6. And then I'm supposed to graph the function. So this coordinate plane is going to have to go up to 6. So let me draw that. And then the widest it needs to go is 4. So something like that. And then we have -2, +4. That will be a point. We have -1, 2, and that will be a point. And that is true when x is greater than 0. So I'm going to put an open circle right there. X is greater than 0. Excuse me, x is less than 0. The function will go this way. Okay, that is the blue part. Okay, let's put the yellow part in. When x is greater than or equal to 0, we would have a 1 and a 2 over 1 up 2, over 2 up 4, over 3 up 6, And then since they have to share that origin, I need to look at this one. I honestly don't remember what to do there. It's been a very long time. So let me look at the chapter review, or the answer key in the back. And that is 189. And it doesn't give me a picture of the graph. So what's the deal there? 189, think about math. 4, 2, 2, 4, and 6. Oh, they gave me the coordinates. They did not show me the graph. I truly do not know what to do here. Because for the blue function, we should have an open circle. But for the yellow one, we should have a closed circle. So I'm going to go ahead and close it just because I'm not sure. I don't think it's going to matter that much. I had hoped they would show me a picture of the graph, and then I could know the answer to that. So this is the yellow portion of the graph that goes that direction.